Are you interested in running your own AI models so you don't have to pay for OpenAI tokens? You'll get the benefit of having privacy, and you can even build cool games with it, which often requires LLM inference, but you don't want your users to pay per token, so you just want the user to use your LLM as much as you want. Well, then Llama.c++ is a very good choice for you, and in this video I will show you everything Llama.c++ has to offer, from quantizing models to running models to benchmarking models and many more things. So at the beginning of the video, you're probably like Ichigo at the beginning of Bleach, not knowing how to do anything, but I promise you, after this video, you have went through your Bankai moment and you definitely know how to handle yourself with Llama.c++ and how to get things done. Well, the Github page of Llama.c++ describes it as enabling LLM inference with minimal setup, and it runs on a wide range of hardware. And this is indeed perfectly what this is. One of the main benefits of Llama.c++ is that it indeed makes it very easy to run an LLM model. You just need a model in gguf format, which I will show you soon, but this basically combines everything about the model, not only the layers, but also the metadata and things like the tokenizer in a single file. And it also allows you to run models on a wide range of hardware. You don't need to have an NVIDIA GPU. You can have one, which will definitely accelerate things, but you can also upload certain things or even the entire model to your CPU. And also M1 MacBooks are really well supported using the Metal framework. So basically on any hardware that you have, of course not on a potato computer, but it will run on a wide range of hardware. But honestly, LLM inference, there are a lot of different options. You might have heard about vllm, you might have heard about ollama or lmstudio, so you're probably confused, like, what do I have to use? All of these offer LLM inference, so yeah, what am I supposed to do? First off, you should note that many of these things of LLM inference are just Llama.c++ wrappers. For example, Ollama and lmstudio are probably the most popular Llama.c++ wrappers, and what these do is just maybe offer some easier way to load in a model. For example, with Ollama, you can just type like ollama run and then a certain model, and it will automatically download it, and you can basically get started with zero setup. But under the hood, it uses Llama.c++. But Llama.c++, I would say, first off, you get access to the newest features, because if you use a wrapper like this, you have to wait for them to implement these changes. But also Llama.c++ offers additional things, such as everything in regards to model preparation, such as being able to turn a model from safe tensor format into a gguf. It also offers quantization, which has become very important in model preparation. It also offers things such as allowing you to, like I said before, compile Llama.c++ to machine code and actually ship it with your application. Also allows you to benchmark your models. So besides LLM inference, Llama.c++ is more like a Swiss knife, that it offers many more things related to LLMs. Well, yeah, these just focus on LLM inference. You also have vllm, but this serves a bit of a different purpose. It requires you to use a GPU, but is also aimed at providing really at serving parallel requests to your model. So if you want to make a model widely available behind an API, well, you should definitely use vllm over Llama.c++, because Llama.c++ is more meant for a single user. So whether you're using it yourself on your PC or you're shipping a model with an application and yeah, only a single user is using that application, so you aren't you aren't processing 100 requests at the same time. So if you want massive parallel inference, use vllm, but for other things, use llama.c++. I also don't have much experience with vllm, so there might be some, you might be more knowledgeable about this. But anyways, we are going to learn everything about llama.c++, so let's get started. The most important thing you need to know is it is available on Github, so just use Github llama.c++ and it should show up right here. Let's maybe do a, let's first of clone it and we will explore it locally. So let's open my terminal, let's go to a nice folder. I will just call it llama.c++ demo, cd llama C++. Yeah, I have way too much folders here, but let's go here and then just do a git clone. It is a not so small repo, I would say. It's also might be a bit confusing, that's why we are going to go through it. Let's go to llama.c++, and because I'm so used to cursor, let's just open it with cursor instead of VS Codes. So let's go right here and open the README. So yeah, let's get started. Okay, so llama.c++, as you can see, it's a pretty huge repo. Let's read the description a bit. So to give you a quick overview of what's being offered, let's see, they offer multiple ways of running models. The first one is using llama CLI, which basically directly runs a model. So that's the easiest way of running it, but you can also spin up a server to get an OpenAI compatible endpoint, so you can use the OpenAI API you're used to. Also tools for measuring the perplexity, and this is basically a measure about how likely your model thinks that a certain text is, and we will look at this later. But if the model thinks a text is very likely of the domain you want to use your LLM on, that is a good sign, and else you might need to do some fine-tuning. You can also benchmark your models, some things for running it more easily. This XCF framework is for an easy way to bundle your application, and I mean easy way of bundling llama.c++ for Apple devices. So if you're developing for iOS, visionOS, or macOS, this is an easy way to get it. But there is so much being offered here. For example, all the things about quantization. Okay, that's right here. I skipped over it, but as you can see, it's probably not clear from just reading the README. So we are just going to go over all of it. So the first thing that we need to do is we need to get a binary for llama.c++, as it's a C++ program, and C++ is not like Python. It runs by having to compile it for your machine. So you have some options. You can download it with a package manager such as Brew, so you don't have to compile it yourself, but then you're missing out on the Python scripts, which are also useful. So you can also, and you also don't really see what's actually being offered easily. You can also run it with Docker, even download a pre-built binary. But I always build it from source, as this also makes it easy to set up certain build parameters. So let's just go to the build guide, open a terminal. But the things that you always need to have installed is you need to have a C++ compiler, and let's see, ins, come on Bookie, let's make this easy, instance txt, and so I've copied it a bit right here, but you need to get some you need to get a C++ compiler, and this depends a bit on the platform that you have. With Linux you can install it like this. With macOS it should come pre-installed if you have Xcode, and a very easy way to check if you have a C compiler is with this command, and it indeed says I have the C compiler. I'm not going to include an entire tutorial on how to do this, but if these commands don't work, just use ChatGPT to solve it. And you also need to have cmake, so cmake, and cmake you can once again install it on Linux as follows. On Mac OS, yeah, just use brew. I think this is the best package manager for Mac OS. And you can also check if you have it with just doing this for cmake version. I noticed that I didn't include Windows instructions, but if you're using Windows, yeah, just install Linux. No, never mind, I just don't have any experience with Windows, so just ask ChatGPT on how to install a C++ compiler there. It shouldn't be too hard. So now that we have this, or yeah, I already had it, so what we're now going to do is do a build. And this depends on which, what kind of PC you have, of course. Let's see, you have a CPU build, which should also work for Mac OS, but it really depends because let's see, if you, for example, I'm working on a MacBook, but if you have a CUDA device, the build instructions are a bit different. I also don't have an NVIDIA GPU, so I can't really help you with the NVIDIA CUDA instructions, but everything should be in this build file, which you can find in the README. But I'm just going to use do the CPU build, which is with these commands, and this will also work on Mac OS. But one thing you can also do is include this dbuild shared libs parameter, and this is a static build, which is especially interesting if you're looking to actually ship the thing that's built in your application, because this will just generate one binary which includes everything, and you can just include in your application. Okay, maybe I'm actually going to do it like that. Let's just copy this, let's paste it in the terminal, and just wait, which can honestly take a bit of time, but I'll see you at the end. Okay, so we see that the build is complete, and so we have this build folder right here, and in the build folder you need to go to the bin, and in the bin you basically see that we have gained all kinds of executables, for example for quantizing, for actually merging LoRa's, for running a Llama server, and we will explore these later. But another thing we need to do for our tutorial is we also need to install some Python libraries, because for example for these scripts which we will be using, we need to run Python code, and this honestly is a bit strange. I think that they didn't code everything in C++, but certain logic which is also essential is hidden in these Python scripts. And to make it even more confusing, like they have this poetry file, but if you install this with poetry, you actually get the wrong dependencies, because you actually need to install this requirements llama.txt instead, which then links to all the requirements that are necessary for the different scripts, which are also listed here. So we are actually just going to install this requirements.txt file. So what we are going to do, first you of course need to have a Python installed on your PC. Just look online on how to install Python. It shouldn't be too hard. Then I'm going to create a virtual environment, which is always necessary. I'm going to select this environment. So let's see, I don't know why it's called poetry, but yeah, let's just select the virtual environment we have just created. Can then verify that we are indeed in the correct environment by calling which Python, which indeed points to the correct one. So what we are now going to do is type the command pip install r requirements.txt, and let's see what it all installs. Okay, we are finished. This took enough time for a quick nap, and we will just later see if anything has broken. Let's first guide you a bit through the most important directories of Llama C++, because this might get a bit confusing. Of course, the build folder, very important, especially the bin folder. Here are all your most important things that Llama exposes. The CI folder is just for the CI/CD of Llama C++. CMake just some other unimportant stuff. Common also unimportant for you. Documentation contains. You can go through this. This is a bit unordered, but this can. Let's see. I don't know. I wouldn't recommend. I think some documentation just refers to this. Not really that important. Examples are important, but they are also, if there is something you want to do but you don't know how, sometimes there is an example. For example, I used this Swift UI example, which I will also use later, which basically showed me how I could actually use this XC framework to build an application with Llama C++ and Swift UI. So for some things, there are actually some examples which you can check out, but this is also not exhaustive, so don't expect this to include anything. This contains some code for ggml, which from what I understand is replaced by gguf. Then what's also maybe important, also these models and stuff, these are just, I think, used for some tutorials, because I don't know why they included even GPT-2 or BERT, which is honestly useless for anything we want to do. Some prompts which are also not used, the requirements for what we need to install, scripts. Some of these can be important. I at least use the get chat template method. So yeah, the thing about Llama C++ is it's all a bit messy. For example, most of these things I would never touch, but this one, by example, I have used the get chat template.py. Source contains the actual source code of what is being built, together with the tools, which is actually the things we are actually also building into binaries. But honestly, the only things you really need to pay attention to is the build folder, the examples, maybe if you don't know how to do something, and these top level scripts these conversion scripts, which we are also going to use. So enough explanation, we are actually going to run some things now. But the first thing we need is an LLM, of course. And for the first few examples, we are going to go to Hugging Face like always. If you want to, for example, see what LLMs I have uploaded, this is my account, but many people are uploading their models here, and what we need is something in gguf format. And let's maybe see, gguf is a very specific model format, like I said, which compiles everything from your LLM into a single file, so you don't need to work with tokenizers and model files. Everything is just simply in one file. And we are going to use first off the lmacpp 4 billion model. And if you don't know much about models, just look at my other videos about my channel. I have so many videos about LLM models, but this one is a very popular model. And Onslaught, which you might know from my fine-tuning tutorials, offers some models in gguf formats. We are also going to look at later how we can turn a random model into gguf. But first off, just to show you some things, let's say if you just want to run some inference, let's download a gguf model. Just choose the one that fits within your GPU. This one will probably fit. This will of course fit on my MacBook because it has 16 gigabytes of RAM. But just use a model that fits within your RAM. I'm going to use this one, which is quantized to 4 bits. So what you can do is just press the download button. So maybe a bit of explanation. These IT models with lmacpp are used for instructions, so there are two variants of LLMs. First ones which just generate text, and others which can engage in conversations. Like I said, just check out my other videos, but we are downloading a model that can engage in conversations. So what we are going to do is make a new folder, custom models, and then just put my gguf in it. Maybe the first thing we are going to do is look at the Llama CLI, because this is the easiest way to run an LLM. This doesn't spin up a server, this just loads in your LLM and does inference. So what we need to do is, I'm just going to copy this path to the build bin Llama CLI. You can, for example, check out which commands it offers by executing help. So let's go through this, what it all offers. Definitely a lot. The most important things are, I'm not going to explain all of this, but first off, the NGL parameters, which basically decides how much of the layers should be stored in VRAM. And VRAM is what your GPU accesses. But to make it a bit confusing, on MacBooks, if you build like I did, by default, all of the layers will be stored in VRAM, because also on MacBooks, they have unified memory, so RAM is VRAM. But if you're using an NVIDIA GPU, you will have to set this NGL parameter. I will demonstrate it later, what it actually does, or how does it actually work. But the most important parameter is the M, by which you can specify the model you want to run. And also you have your usual sampling parameters, such as temperature, which a lower temperature makes your generation more deterministic, because it scales the distribution of your output tokens that your model will predict by forcing it to be more random. Also things like top K, which determines how much between the K tokens that have the most probability mass that the model will actually decide to sample the next token. So if you increase this, it will take into consideration more potential tokens. Top P also, this only if you set this to 1, it basically considers all the tokens. But if you set this lower, it will, for example, if you set this to 0.9, it will only consider the tokens which have together a 0.9 probability mass. So some very unlikely tokens might not be included. I think I went over a lot of these also in my fine-tuning video, but there are a lot. So just look online if you don't know what a certain parameter means here, but most of these should be familiar to you. Also things which I'm also going to show is things like grammar and JSON schemas. And by passing these, you can constrain the output of the model to only generate, for example, valid JSONs. So if you want to have structured output, I will also show this later, you can use this. And this way your the outputs of your model will always be according to a certain schema. But yeah, there are a lot of parameters. Also chat template is definitely important, but I think if this is not specified, then by default one is taken. So this is mainly important if your model gguf doesn't specify a chat template. I will also have an example of this later. But anyways, let's just do build. I've already copied it, and we are just going to do the m parameter and then also copy the path to my model, and yeah, not specify anything at all. It will just load my model. You will see it as found the Apple M1 Pro. It takes a while initially to load the model, but it should, after it's loaded, we should be in interactive mode. Some things you can see, it has found the correct chat template of the Llama 3 model. And now I can type something like, how are you? And this is just like ChatGPT, and we are just doing inference. Then I can type, yeah, give me Fibonacci code for Python. And we are just doing LLM inference locally on my MacBook with a model. Some other interesting parameters, like I said, is the NGL parameter, which I don't really need to set on MacBook, but this determines how many layers are assigned to the GPU, which by default is all on my MacBook, but with NVIDIA GPUs, you can set this, for example, to 99, which should allocate all the layers to the GPU. So we can still already do this. So let's, for example, type, how are you? Generate a story. And it's not the story itself that I'm interested in, but I'm mainly interested in the tokens per minute that it generates. So we already have some sampling, so let's cancel it, and it will says here in eval time that we generated around 43 tokens per second. But now when I, for example, would type ngl0, this should be much slower, because this forces every layer to be every token to be processed by my CPU, and CPUs aren't that good for inference. So let's run it, generate me a story. But it's still quite fast, and that's also the beauty of Llama C++, is that we can still run inference on the CPU, and if you don't have enough VRAM to really take in a very large model, you can assign certain layers to the CPU, certain to the GPU, and that's really honestly quite quite amazing. So we have enough. So, and now you can see we only generated 25 tokens per second, so half the speed of when we were assigning everything to the GPU. But on MacBooks, yeah, we don't pass that option. Another thing, yeah, we were just doing a quick pass-through, so let's also show you some other cool things in the bin folder to run LLM inference. For example, what's also important is this Llama server. And this accepts, as you can expect, also just almost the same parameters as before. But what this will do is this will really spin up a server. So we can also assign a port, for example, a really high one. And now you see the model has been loaded in on a port. And yeah, you basically get a cool a cool UI you can use to chat. And what this also allows you is to really, just like with the OpenAI API docs, I think, yeah, OpenAI basically deprecates this, but this offers an completion API compatible endpoint. So you can basically call your Llama C++ program using the same API as OpenAI offers. So you pass messages as follows. So this is really useful if you're building an application and you want to have an API available. You can call in your code and have some server. So Llama C++ server is really meant to do that. Okay, then another cool thing you might do is use Llama bench, and this will run some benchmarks, which takes a while, but you can use this to experiment with different settings or different LLMs. And you can, for example, see that it will run two tests, the PP 512 test, and you will see how many tokens per second you get right here. And then it will also run the TG test, and you will see you will get this many tokens. But you can just like anyways use the help command, and you can experiment with different parameters, for example this NGL parameter or other things. And yeah, you can basically benchmark your LLM. Another thing which can be very cool is, like I said, the perplexity measure. So this is really useful for if you are if you want to test how well adapted a LLM is to a certain domain. So you're basically going to point to a file. Yeah, I'm just going to maybe point at the README, and it will just README MD, and it will just make the LLM estimate how likely it is that this file would be generated according to LLM. So it gives token per token to the LLM, and it will just look at the probabilities that it gives to the token that is specified in the README. So it, for example, given LLM, it will check how likely it is that inference is generated as the next token. And if this file is very likely according to the LLM, you will see that then the model is very well adapted to the domain. So we'll see we have a perplexity of 7.6. So how you need to interpret this is that basically on average the model thinks that 1 over so let's maybe calculate this real quick. So it thinks that every token is on average around, the correct token is it gave it a probability of 13%. So this actually is not bad. So at least this Llama model is a bit adapted to a technical domain such as this README. Another thing I want to show you is how to do structured outputs, because this is really useful, especially if you're building applications and doing some kind of predictions with an LLM and you don't want the LLM to generate freely. Let's just go back to our llama CLI commands, and then what we are going to do is pass a JSON schema, which I'm just going to copy with the J parameter. So what I specify right here is a JSON schema that I only want the output to basically be a dictionary with a name parameter, which is a string, and an age parameter, which is an integer. JSON schema is very popular. Also, when you're using things like Pydantic JSONs, if you're using Pydantic in Python, you can also easily use this to dump a JSON schema. If you've ever used a Python API, the Python OpenAI API, you know what a JSON schema is. So that is totally supported with Llama C++. And what you can then do, is then, for example, provide a prompt. For example, let's name all the football players of Barcelona 2005, and normally it would just generate some free text, but now it should generate a valid JSON. And you will see indeed it gives me a JSON schema just like I specified, with a list which contains for every player the name and the age. So this is personally very useful. Another thing I want to show you, but this is more a bit to understand Llama C++ a bit more deeply, which I was personally a bit struggling with at first, is that you should understand that the model isn't always loaded into memory. So when after running the server and maybe interacting with it for a while, what I didn't understand was when I went to top, I didn't even see the model showing up as having much RAM usage, which you can even clearly see with htop. The thing that was using the most memory on my PC still is just using the Chrome app, which is, Chrome takes up a lot of memory. And when I would search for example, the things related to my Llama server, it also was taking up like 300 megabytes, which honestly, like the model itself, the file is 2 gigabytes, so I didn't understand how my RAM usage was so low, and that was because I didn't understand that instead of loading the entire model in memory, what's actually happening is that we are using a memory map. So when I can clearly show you it like with this command. So here you need to type in the process instance ID of the Llama server, which you can find with the top command. And what you then can do is type in this command. And right here you see the gguf we are using, the Llama tree, but you will see it's memory mapped. And what this means is that it is still on disk, this file, so it's not in your RAM memory, but we are only loading in the pages of the file into memory when they are used. And after they are not used, for example, we are done with our I type hello and it generates the tokens, the completion tokens. And after the completion is done, it will load everything back. It can boot all your almost your entire model back out of memory. So yeah, what you just need to understand is that that your entire model isn't always loaded into memory, which is a beautiful thing that Llama.cpp does. But you can manipulate this with the, where is it? With the no-mmap thing, which basically says that first off, when you start the model, load everything in RAM, so don't leave things on disk. And what you can also do is the mlock, which basically says that once the model is loaded into RAM, keep it into RAM, so don't swap it out back to disk, keep it in RAM. But honestly, you should probably not mess with these parameters. Okay, but now we are also going to not only look at inference, but also model preparation. Because, for example, it is often the case that, or not often, but it can happen that you want to use a new model, for example, that came out, for example, this GPT OSS, and they don't really release them in gguf format, which is required for running them in Llama.cpp. So you either pray and find and hope that someone else uploads a gguf, or you convert it yourself using Llama.cpp. So I'm going to show you how you can do that by we are going to do it with Llama 3.1, 8 billion, the unslot reupload, and you can see it's also in safe tensor format, so no gguf. So safe tensor is very common. So what we're going to do is we are going to clone this model from Hugging Face in our custom models directory, and this can honestly take quite a while, so yeah, take a nap or something. Okay, so it took a bit too long. I just went to sleep, woke up again, got an entire day of work done, went jogging, and now we're back to go further. And let's show you how you can prepare this model. Because Llama 3.1, 8 billion, it's 16 gigabytes in total. Each of these safe tensors is around 4 gigabytes, so it's way too much to run on my PC. But the first thing we of course need to do to run it at all is to turn it into a gguf. And to do that, Llama.cpp offers these, let me show you these Python scripts, and that's why we also installed this virtual environment before. So when I check which Python, we can see that we are indeed using the virtual environment. But the first thing we need to do is use this convert Hugging Face to gguf script. I think you can view the options as follows. If you just type Python and then help, it will show you all the options that you can do with this. But for now, we just need to input the model with the which is a positional argument. So we don't need to put on a flag, and we only need the output file flag, which will indicate how we want the output file to be called. But it's very easy. So what we're going to do is Python convert Hugging Face to gguf.py, and then we point to our custom model, which is this Llama 3.18 billion. Oops, I'm typing something from somewhere. What the hell? Okay, I think my control key got stuck for a while, but what we then need to do is only type in the out file parameter, and this indicates where we want to, oh damn it, I click the control again, and what we are just going to do is we are going to give it the same name and just give it a gguf extension. So when we run this, the conversion should start. Indeed, we are starting to convert the entire 16 gigabytes. Okay, so we now have this gguf file. I'm just going to delete the save tensor thing because I'm running a bit low on disk space and I don't want to crash the recording. I should really clean up my PC any day now. But still, this model is still way too large to run. So what I'm now going to show you is how to quantize your model. For example, the first model we ran, this Llama 3 model, was already quantized to Q4 0. So now we are going to quantize our LLM as well. And this happens. Once again, it's a bit confusing. This doesn't happen with a Python script. We once again need to go to this build directory, and here you can find llama quantize, and this is the script we need to run. So let's first maybe show you which options that are available. Llama quantize help. And you will see these are the options. I think the most important one is basically that we need to pass the quantization we want, and we can choose between many options. Floating point 32, floating point 16. These aren't really quantizations because most of the time it isn't floating point 32 or 16, but we can also do it in 8-bit quantization. I think the most popular, at least for me, is this 4-bit quantization, the Q4KM. As you can see, there are a lot of different variants, even the Q40 that we saw with the Llama model. But honestly, the only really useful options are these 8-bit quantization and these 4-bit quantizations, and you can vary a bit. But we are going to use the Q4KM. So how does this script work? Well, let's just type llama quantize, and then we need to point to our gguf that we want to quantize. So this one is this. And what we are then once again need to do is specify where the output file, so the quantized model, needs to be written to, and I'm just going to write it in the same directory. And it is normal, or the convention, to put the quantization at the end of the model. So if you upload it to Hugging Face, people can clearly see what quantization it is. And then we type the quantization we want. I'm going to use this Q4KM. And you can see that the conversion is happening. Okay, with the quantization is done, and we see we have converted a model that was around 16 gigabytes to now a model that is 4 gigabytes, which is stored right here. And basically, yeah, we are just going to see if we can run this model. So once again, use the llama CLI option, specify the model as follows. But a difference is that we are now using a completion model, so not an instruct model. So this model will just complete text instead of answering questions like you're used to with ChatGPT, because it's just a base model. It hasn't been supervised fine-tuned yet. So if I type hello I am, the model will start completing it. You can provide a prompt with a p parameter. So let's see what it writes. And it says, hello, I am April 1st, 2018. Quite a weird completion, but often with untrained models, they can just generate some concepts. But honestly, yeah, these completion models without fine-tuning, they aren't very useful. But anyways, now I can show you another interesting thing, and that is how to run LoRAs. If you've ever fine-tuned something, you know what a LoRA is. If you are looking to learn how to fine-tune, I would recommend checking out my guide on it. And also my latest video about fine-tuning was about fine-tuning a Donald Trump LoRA, which I did by fine-tuning on a lot of interviews of Trump, and I basically made Llama 3.1 behave like Trump. So what this is just as you can see, a small set of weights, only 160 megabytes, which are put on top of the base model. The weights are, for example, added together, and this way the behavior of the model changes and he will start acting like Trump. So let's see how we can, because this is once again only in safe tensor format, how we can first off turn this into a gguf and then use on top of our base model in Llama C++. So what we need to do is, of course, first once again clone this. And what we then need to do is turn it into a gguf. It's important to not use the HEF to gguf like before, but you need to use the LoRA to gguf, else the thing will simply fail. So we will just type Python and then the name of the script. And then we need to define which model we want to convert, just like before, but this time we are going to convert the LoRA. We need to define the output model, but just call this .gguf. And I think, yes, I need to specify this with a flag. So this should work. Can't open file. I'm in the wrong directory because as you can see, I am in the custom models directory here, so I need to do it from here. See how fast that already went, and we now have this LoRA gguf. And what we can now do, very interesting, is build bin llama CLI, and as you can see in the help, this has a LoRA flag, which we can then point to our adapter, which we will do right now. And another thing we need to do is, because this is a completion model, we should point to a chat template file, because I have fine-tuned it on to act like Trump and to behave in conversations, but by default Llama C++ will look at which chat template is defined with your base model, so in this case the Llama 3.1 gguf, but let me show you. Let's open both. You will see that, okay, this is, I can't view this, I think, or maybe I can. So you can see with the base Llama 3.1, the completion model I'm using, if you go in the tokenizer, okay, I'm not authorized, let's go to the unslot library then, Llama 3.1, 8 billion and 8 billion instruct. So what you will see with the base model, if you go to the tokenizer config, you will see if you go searching for chat template, no chat template is found. So there's no way to convert your incoming message and the completion of the assistant into a string, which the LLM will learn that it is about a conversation and will know how to answer it. But once we go to the instruct variant, this one has been fine-tuned on a chat template. If you go to the tokenizer config and then to chat template, you will see there is a Jinja template right here, which, if you will look at it, it is just a template. It will define some options, such as the way to format your messages. You can set a system message. I'm not going to look at it in depth, but Llama C++ will try by default to load the chat template if it's included in the gguf, but because I'm using a completion model, no chat template is provided by default. So you can either use this chat template flag and just specify some built-in chat template, or you can write your own Jinja template file by, you will have to learn how to write Jinja, which is a templating language. I don't know much about Jinja myself. I usually just use a chat template of one of the existing models if I'm fine-tuning, but you can write your own one, and then you will have to copy this to a file and point to it like that. But we are just, as you can see, Llama 3 is included here, like with most models, so we will also need to use that. Enough talking, we will try to run our LoRA. So take the Q4 KM gguf, then we specify that we want to run a LoRA on top, and that is this Trump gguf. And what we then need to do is still specify that we want to use a chat template. So we are going to do chat template, and then we specify Llama 3. So I think this should work. And now we can ask, who are you? And at least the first sentences should be that he is saying, I'm Trump. I'm Donald J. We did a lot. We made America strong. And the model isn't very well fine-tuned on multiple conversation turns, because I only fine-tuned it on question-answer pairs. So after a while, it goes a bit off track. But at least for the first few questions, it will answer what you're asking. For example, let's ask, what is your favorite food? If a fantastic steak cooked to perfection. So if you want to learn how to fine-tune, check out my other videos on my channel. I have lots of them, but you can see we can run a LoRA like this. But what if you don't want to ship to different files? For example, you want to give you fine-tuned a Trump model, and you just want to give a gguf to your friend, and you don't want him to have to learn how to run a LoRA on top of it. Well, what you can also do is just merge the LoRA together with the base model, and then you have a single gguf file which you can distribute, which might be for some use cases more helpful. The downside is, of course, that the model is really changed. The base model, you changed the base model, so else it's, for example, possible I could have an application where I train a different set of LoRAs for specific use cases, and I can dynamically switch them, which of course, if you merge it, it's no longer possible. Let me delete that quantized model real quick, because what we are going to do is we are going to merge the model together, and you shouldn't merge the LoRA with the quantized version, but really with the base version, because else some weird things can happen, and the quantized version will first be dequantized, which can introduce some errors before the merging happens. So we are just going to use the unquantized gguf version and merge it with the gguf version. Merging only works on gguf files, so you do need to have converted them to gguf before. And the way you can merge these things is with the llama export LoRA binary, which we can invoke as follows. So we are going to once again do llama export LoRA. Then we are going to specify our base model, which is this gguf. Then we are going to specify the LoRA which we want to merge it with, which is this. Then we are going to specify how the output file should be called. I'm just going to call it custom models Trump merged gguf, you should probably write something more descriptive, which also mentions the base model and stuff, but I'm a bit too lazy. Invalid argument. I mistyped it. So you will see that that some dequantizing happens, and this can introduce errors. So it's best that you start from a unquantized version. Okay, we now have our Trump merged gguf in our custom models. However, it's still 16 gigabytes, so we once again need to quantize this one. So once again, you know how this works. Build bin llama quantize. We are going to point to the model. Then we need to specify the output file, Trump merged, and just call it q4km. And then we specify the quantization, which will be q4km. Okay, we have quantized it. So now let's run once again this model. Okay, I was doing something wrong. I forgot I need to run the quantization instead, because else, of course, it's going to error. Hello, who are you? I'm Donald J. Trump, a very successful businessman and winner. Okay, you can see that this is working. Now let's finally let's look what if you wanted to build an application and you want to include llama.cpp into it. Well, the thing is, you can compile llama.cpp to a binary, to a C binary, but then you would still need to write your own bindings in your favorite programming language called the methods of the C binary. So what is offered is, let's show you right here, bindings, and you can see what this basically means is you can just use these bindings. It's just a package you install, and these will have code in your favorite programming language, which calls the C binary, which is also included with the installation if you install these binaries. So I'm going to, for example, show you, let's say you're building an application in Python, but you also have things for Swift and Rust and any programming language you want. And let's say I'm building a Python application and I want to ship it together with llama.cpp. So what I need to do is install these Python binaries, Python bindings. As you can see, this will also build llama.cpp from source and install it. So you have a llama.cpp binary which you can interact with using Python. So let's make a tutorial notebook. I like using notebooks for this, but yeah, you're free to use whatever you want. Let's select my Python virtual environment, and what we need to do is pip install llama.cpp Python. First I need to install the, there is no pip installer. What? Maybe let's just run it in the terminal instead. So, and yeah, you can look up the complete documentation right here, how it works. I also think they have a good link right here, which you can read more in depth. For example, how you should call this, how you should do function calling, how you should do JSON mode, a lot of different, everything llama.cpp offers you can then do with your favorite programming language. So let's, okay, that's the beauty about Cursor, that it will give me some completions the wrong ones though, because this needs to be Llama C++. Let's see if everything is installed. What is this complaining? There is no pip installer available. Does it now work? Okay, I just needed to install it through the terminal, and what I can now do is load in my LLM as follows. LLM is llama, and then the model path, and the model path, let's in this case once again use our good old Llama 3 model. And then we can just, let's load this in first. Put it in, let's see if it works. We can do this with a very similar API. Yes, very similar methods as how you would call the OpenAI API. So we just provide messages and then a dict with the correct roles. Role user. So this is single term conversation content. Yeah, let's just ask this. And you will see, hello, I'm doing well, thanks for asking. As an AI, I don't really feel the way, but you can see, you can chat like it like this. Compile your, bundle your application. If you're developing in Python, you can bundle applications and ship it like that. Of course, you need to include your actual model in the application, but yeah, I would recommend using these bindings, and don't, if you want to write them yourself, you can also do this, but I would recommend this. So in general, I hope I at least explained everything that I personally know about Llama C++. I also think these are the main things you should know. Definitely let a comment if about what you found about this video. If there are still some things that are unclear, don't hesitate to also ask it, and I hope I see you in the next one.